Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face Trending List, published on February 17, 2026, just 3 days ago. It finds that when in-car AI assistants provide intermediate updates during complex tasks, it significantly boosts user trust and perceived speed while actually lowering the driver's mental workload compared to staying silent. The paper is titled, "What Are You Doing? Effects of Intermediate Feedback from Agentic Large Language Model in Car Assistants During Multi-Step Processing." And as we'll see later, the insights on balancing transparency and distraction are really valuable for anyone building autonomous agents. And for those interested in the implementation, the authors have shared their code on GitHub. To visualize the core challenge, Figure 1 compares the two feedback strategies tested in the study. On the far left, a user makes a complex request, specifically asking to navigate to a contact and check battery levels, which triggers a sequence of background tools. The top orange row shows the silent baseline, where the assistant offers a generic planning message and then goes quiet. Contrast that with the blue row at the bottom, which illustrates the proposed method. Here, the system explicitly narrates each step, confirming when it finds a contact or calculates a charging stop. So to evaluate this in practice, Figure 2 shows the study apparatus. The researchers set up a dual task environment, where participants sat in a car mock-up, focusing on a driving simulation displayed on the vertical screen labeled 3A. To keep the physical effort consistent, they actually used a mouse, labeled 3B, to steer the vehicle rather than the wheel itself. While driving, they interacted with the assistant via the center display, shown in close-up on the right, which provided the visual cues for those planning steps and results. Alright, Table 1 breaks down the specific variables controlled in the experiment to isolate these effects. The first factor is feedback timing, comparing the silent no intermediate baseline against the planning and result method, which provides those progressive updates. Then, to test if the benefits hold up during longer waits, they varied task duration between a medium 26 seconds and a high 45 seconds. Finally, they toggled the interaction context between a simple stationary setup and a complex driving scenario, which helps determine if the extra audio feedback becomes distracting when the user is already busy. Figure 4 visualizes exactly how these interaction flows differ in practice. The top half illustrates the medium duration task, lasting 26 seconds. In the orange baseline row, the assistant acknowledges the request, but then remains silent until the end. By contrast, the blue row shows the proposed method providing updates every 5 seconds, confirming steps like searching for a McDonald's. The bottom half demonstrates the high complexity scenario, which runs for 45 seconds. Here, while the baseline stays quiet for over half a minute, the active feedback condition fills that gap with 6 discrete status checks, keeping the driver grounded. Well, Figure 6 presents the quantitative results from those trials, comparing the silent baseline in orange against the active feedback method in blue. Across the board, the proposed system performed better. On the far left, you can see that perceived speed scores were significantly higher for the feedback condition, meaning users felt the system was faster even though the actual processing time was identical. Moving to the middle, both trust and user experience ratings also saw a clear boost. Finally, the plot on the far right reveals that task load actually decreased. This is crucial because it suggests that hearing intermediate updates does not distract the driver. Instead, it lowers the cognitive effort required to monitor the system. So digging deeper into that speed perception, Figure 7 plots how users felt about the wait times as the tasks got longer. The chart compares medium 26-second tasks on the left to 45-second tasks on the right. Notice the orange lines for the silent baseline. They drop steeply, meaning users penalize the system heavily for the extra delay. By contrast, the blue lines for the feedback condition start higher and stay almost flat. This proves that intermediate updates buffer the sensation of time passing, keeping perceived speed high even when the system takes nearly twice as long. Wrapping up, the main lesson is that ambiguous silence creates anxiety in high-stakes environments like driving. Intermediate updates make agents feel faster and more trustworthy, while actually reducing the driver's mental effort. The study points toward adaptive verbosity as the ideal design, starting transparent to build trust, then streamlining updates once the system proves reliable. That's it for this episode of the AI Research Roundup. I'm Alex, thanks for listening.